through the rest of this because I'm worried about time, actually. All right. They tell you about this enemy drone that's coming out of the sky. What information did they give you about this enemy drone? Yes. They tell you where it starts. 500 minus 300 sound right? I make up numbers, so you have to check me. Right? So you have an enemy drone. It starts out at 500 minus 300. They don't tell you how fast it's going, but they give you some other information. So I'm looking at my notes here. Yeah, so you don't know the equation for the enemy drone, but you do know that it has to be like this. Here I went back to your notation from high school physics. V sub x, v sub y. This is not given to you. They didn't give this to you. And but they ask you what velocity it has to be to intersect. Did they ask? Is that what they asked you? I'm just looking at my notes. Read your PSL. Is that what they asked you?
Build a vector equation modeling the enemy drone's motion at a given time as it flies to intercept the friendly drone.
Okay, but they don't give you this. They don't give you these guys, right?
I thought they gave you the speed of the drone and the rest.
Yeah, they do.
Tell you which direction it's going.
It says that it's flying at 31 meters per second and unknown heading.
Where?
On task 2 on the scenario. It doesn't.
Yeah, it is.
Flying at 31. Because we're still on task 2.
We know it's flying. We don't know the velocity vector because we know it's flying.
Okay. So when will this is what you want to do. When will two things collide with each other? If one's on this path and one's on this path, when they intersect. When do two lines intersect? How do you figure that out using 7th grade math? You set them equal to each other. So this is the formula for your reconnaissance or your enemy drone. Up there was the formula. Somewhere along the way, we had the formula for our drone that we sent out. Set them equal to each other. What did I call the other one? RR? The other equation, I forgot what I called it. Like little r, yeah. So I called it like R, E. Like, did I do this?
Yes.
Or did they do this? Did they do this in your notes? I forgot.
Yeah.
So you set them equal to each other. So you have on one side, you have, I forgot the equation already, minus 300. And I'm going to do this. I'm going to do plus t. I'm going to pull the t and the 15.556 and the minus 300. I'm going to do this because I have to do this anyways. And I'm going to do the other equation the same way. I'm going to set that equal. So I get 500 plus tvx plus and comma minus 300 plus tvy. For this one to hit that one, they have to intersect, they have to be equal. From the way the two vectors are equal is if their components are equal. So from that, I get one component and a second component. I'm going to set them equal to each other. So equation 1 is going to be minus 300 plus t times 15.556. I'm going to set that equal to 500 plus t times vx. That's just setting this guy equal to this guy. Your x's have to be equal and your y's have to be equal. Your second equation is going to be this minus 300 plus t times 15.556 has to be minus 300 plus t times vy. And that just comes from setting this guy equal to this guy right here. YZ's have to be equal, XZ's have to be equal. Make sense? The second equation, I'm glad. Nothing else made sense until now?
It's starting off.
Okay, I'm going to ask you in a second, and I'm going to I remember teaching a pre-calc and saying, asking people, I understood you, I somewhat understood you, I had no idea what you were doing at all, and the entire class chose the last. I have no idea what you're doing.
So how do you, if you're setting the two equations equal to each other, what do you do with the Vx and the Vy?
You're trying to find the Vx. You
So
don't know it.
Okay.
So I'll tell you right now, start with equation 2, solve for V out. You're going to be able to cancel stuff out and solve for Vy. So use this one to solve for Vy. Huh? Yeah. I'm not going to finish this. You guys do it. Start with equation 2 and solve it, because I want to finish you guys on this project, on this thing, at least the directions. Let's see.
So t cancel out.
Did you set your equation? Do you have these two equations? Yes. Well, why are they still inside your vector forms? And mine are not. I pulled them out. I set my components equal. So this is my x component here, and it's going to be set equal to my x component here. So that's my equation 1. Then I have my y component here. I set it equal to the y component here, and that's my equation 2. Yeah, the 300s are going to cancel, and then you're going to get the t's are going to cancel, and the only variable left on the second equation is going to be vy. I'll give you the answer too, so you can shoot for it. Okay. Your vy is going to be 15.5656. Should get. And then they told you that your speed is constant. The magnitude of your speed is constant. That's what they gave you. So what that means is that your vector VE, which equals, this is the information they gave you. They gave you that VE has to be equal to 31. That's what they gave you. That's the information they gave you. You know Vx. You know what this thing, the formula for this thing. So you set it all up to solve for, you know Vy, sorry, that you're going to get Vy from this calculation. And then you plug this in. And I know I'm rushing, but I'm recording this. Sorry, 31 squared. And now you can solve for Vx.
So you still do the Vy one first?
You have to do the V1 one first.
What's the reason?
It's just a made-up problem. It's a made-up problem like this. All right. I'm recording this. So if you're not catching all this, it's going to be put on YouTube. so you can look at it. I don't know what to call it because I don't want other students from the other sections to go and look at it without what we did. They didn't do the boards. They're not tracking them. You'll be surprised.
If I watch this back, I don't know if I'd be able to get it.
Well, I've been told before that the best thing about recording videos is that people can slow me down.
Right.
For equation, solve it the same way.
You can't, because there's a t that you can't get rid of and a vx that you can't get rid of.
So you just have to wait until the numbers cancel.
You have to use this piece of information to finish it.
But what if both of your equations, what if like the 300 did cancel for the first one?
Then it was a made up problem, so they made it up so that you could do it this way.
So we won't have one where one of the, okay.
Yeah.
Where is the 31 from?
It goes in the problem. They told it to you in the problem.
So,
Competition.
if you were able to know, I understood this part of getting the PY, then how do we put that back into?
But I still don't have the vx.
Okay, so
So I need to use the other piece of information they gave me to get the vx. Once you have the vx and the vy, you have the equation for the then you have this. You have, so you should get, so you can get your answer, that vx should be, I'm going to grade your work. Your vx comes out to be the square root of 719 plus or minus. You'll get something squared, so you have the plus or minus. One of these is going to work and one of these is not, because your time needs to be positive too. And so you have to go back into your equation. And 1 second, let me just put this down so you have it. You'll solve for t. You should get a t of 18.886. I think the negative square root of 719 is the one that gives you that. So one of them won't work. But now you have the time that when they crash, they're going to crash. And they're going to crash at 18.886 seconds. And once you have that, you'll have both VE and VT and VR, the reconnaissance and the enemy velocities. The last question they ask is, are these two orthogonal to each other? Because if they are, it's going to be a kill. Dot product has to be 0 for it to be orthogonal to each other. So you would take the dot product of these two guys. Last thing that you have to do is this. And check out what it equals. If it's 0, it's a kill. If it's not 0, it's a not kill. And it turns out to be not 0. So the answer is will be a not kill. So you should get that. Slow me down. It did take me myself 2 hours to go through this and figure it out. And I'm good at reading these things. So I had to really distill it. And I have ChatGPT too. Look at it and go, did I understand this right? So I asked a lot of questions.
The final answer you should get to is it does not.
Yes. But that's not where you're going to get graded. These computations. Right.
Do intersect, but it doesn't.
They do intersect. They intersect at time equals 18.886 seconds.
So why is there a kill?
Because they made a condition that it has to intersect at a 90-degree angle. And two vectors are 90 degrees apart if the dot product is 0. Right?
The last thing, what are you talking about?
Dot product is important because dot product tells you the angle between the two vectors. We did that the first day. How close are these two vectors to each other? And cosine similarity. When they're completely apart, 90 degrees apart, the vectors have a dot product of 0. And
So,
do you remember the two examples we had with the two words? Like one was a mathematician proved there, and they had nothing to do with each other. And then when you calculated the dot product, it ended up being 0. So then they want you just to do this calculation. And shift all that does not zero.
That's why I have it.